Good morning, 7th grade. I'm sorry I can't be there with you, but we are going to go ahead and finish up this chapter anyways. So we are finishing up lesson 5.8 on operations with scientific notation. And yesterday we did multiplying and dividing. Today we are doing adding and subtracting. So, if you recall, when we were changing, after we would multiply or divide yesterday, sometimes we would end up with a number that wasn't in scientific notation. So we might end up with like 20.7, so 20.7 times 10 to the 5th. And we said we would have to convert that number so that it's actually in scientific notation, and to convert it, we move our decimal and our exponent in opposite directions. So we would move our decimal to the left, and we would move our number of our exponent to the right on the number line. So this would become 2.07 times 10 to the 6th. Likewise, if we ended up with an answer like 0.49 times 10 to the 2nd, if we would move our decimal to the right, then we have to move our number to the left on the number lines. We would end up with 4.9 times 10 to the 1st. So we're going to have to use that today whenever we are adding and subtracting. So you want to make sure that you remember which direction to move things, and remember that they move in opposite directions from each other. So to add and subtract, you need to think of like when we add and subtract fractions. So think back to adding and subtracting fractions. When we have 2/4 plus 3/4, we can just go ahead and add because we have a common denominator. We say they're speaking the same language, like it's broken into the same size parts. So we could just add this straight across the top, and we have 2 plus 3 is 5, and then we keep the denominator of 4. It's a very similar idea whenever we add or subtract in scientific notation. Instead of having denominators, we have powers of 10. So, for instance, if we have 5.6 times 10 to the negative 7th plus 2.9 times 10 to the negative 7th, these are in the same powers of 10. We have a 10 to the negative 7th, and we have a 10 to the negative 7th, which means they are speaking the same language. So all we have to do is add our leading numbers. We add the 5.6 and we add the 2.9, and if you need to, you can put it in your calculator, or you can go over to the side and do scratch work, or you might be able to do it in your head. We get 8.5. Okay, so our numbers are added. We have 8.5 now, and we keep the power of 10. Just like we keep the denominator, we keep the same power of 10. So we have 10 to the negative 7th. It's the same for subtraction. So let's do a subtraction problem. We have 6.4 times 10 to the 5th minus 3.79 times 10 to the 5th. Again, our powers of 10 are already the same. We have 10 to the 5th and 10 to the 5th, so we're good to go ahead and just subtract our numbers. So we have 6.4 minus 3.79. And you can maybe do that in your head, or you can punch it in your calculator, or if you have to do scratch work, remember that your decimals have to be lined up whenever you add or subtract, which means in this case, we're going to have to stick a 0 in there as a placeholder. 10 minus 9 is 1, 13 minus 7 is 6, and 5 minus 3 is 2, and our decimal comes straight down. So we end up with 2.61 and times 10 to the 5th. We just keep that power of 10. So these are all good whenever we don't have or whenever we already start out with same powers. However, sometimes they will throw some at you that are not the same powers. For instance, what if we have 2.5 times 10 to the second plus 3.1 times 10 to the third? If we were to just add these front numbers, our answer would not be accurate because we have unlike powers of 10. And if I actually write these out for you, so let's write out 2.5 times 10 to the second, that would be move our decimal over 2 places, right? So let me write it out. 2.5, we're going over 2 places, so we end up with 250. And 3.1 times 10 to the third, we would move our decimal 3 places. 1, 2, 3. And we end up with 3,100. And when we add these, we would actually get 3,350. If we, this is what not to do, if we were to do the 2.5 plus the 3.1, we would get 5.6 times 10 to the we don't even know what, because there are no properties for adding powers of 10. Remember, our properties for adding, or for our properties for powers of 10 are for multiplying and dividing and having exponents with them. There is none for when we add powers of 10. So we would have an unknown power of 10 and we'd have 5.6, which 5.6, no matter what power of 10 we chose, would never get us anywhere near the actual answer of 3,350. So, in order to add these, we're going to have to do what we talked about here at the beginning. We're going to have to we're going to have to move our decimals so that we have the same powers of 10. You might say, well, which one should I move? Should I move this power of 10 or this power of 10? It really doesn't matter. However, if you always go towards the bigger exponent, like make them both the biggest exponent, it's going to make your life easier at the end. If you go towards the smallest one, you're probably going to have to do some additional converting at the end. So let's just give this one a try. We want to make 2.5 times 10 to the second something times 10 to the third. So if I need to move my exponent on the number line one direction to the right, that means I'm going to have to move my decimal one place to the left. So I end up with 0.25 times 10 to the third. I don't have to do anything to this second number because it is already 10 to the third. Then I can just add up my numbers. So I have 3.1 and 0.25. Put in our 0 as a placeholder. We have 5, 3, 3. So we have 3.35. And if you remember, over here we had a 3, and 5. So that looks pretty good. It looks like we're on the right track. So we have 3.35, and this is times 10 to the third power. And that's because we keep our powers of 10, because we ended up with 10 to the third and 10 to the third, and we keep the 10 to the third. This is our final answer. If you wanted to double check yourself, just like we stretched it all out here, you could stretch it out. And when we stretch this out, that would go over 3 spaces, 1, 2, 3, which is 3,350, which does match what we said it would. So we've kind of proved that what we're doing is working. It's the same exact thing for subtraction. When you subtract, you just have to change your powers of 10 so that they are the same power of 10 once again. Before we do a subtraction problem, though, let's do this same exact problem one more time. Last time we went to the larger exponent, which is, I said will give you less work at the end. This time let's go to the smaller exponent just to prove that we can do it and we will get the same answer. It's just going to take an extra step in there. So if we're going to take this 3 down to a 2, that means I'm moving my number to the left on the number line, so I have times 10 to the second, which means I'm going to move my decimal the opposite direction, or to the right in this number, so I end up with 31. So now I have 31 times 10 to the second plus 2.5 times 10 to the second. And when I add these, I have 2.5 plus 31, so that's 31 plus 2 is 33.5, so we end up with 33.5 times 10 to the second, because we just keep the same power that we had. So we had 10 to the second, 10 to the second, we keep 10 to the second. However, this answer is not in scientific notation, so that's why we have one extra step that we have to do, where we have to move our decimal so that our final answer is in scientific notation, which means I'm going to move it one direction this way and one direction that way, which ends up giving me the 3.35 times 10 to the third. So if you forget and you do it this way, it's not a problem. You can go this direction. You just have to remember that at the end, you're going to have to do one extra step. So let's do one more addition problem, and then we'll do a subtraction problem, and then we'll be done for the day. So we have 4.2 times 10 to the third plus 5.13 times 10 to the fifth. I wanted to do this one because this is an example of needing to move the decimal 2 places. So in this case, we're going to go 2 places on the number line to reach the 10 to the fifth. So we're going to move this decimal 2 places, which gives me 420 times 10 to the fifth plus 5.13 times 10 to the fifth. Now we have our same powers of 10, so I can just bring that down, and I end up with times 10 to the fifth, and it's just 420 plus 5.13, so it's 425.13 times 10 to the fifth. So subtraction is very similar, except for subtracting. So if we do one, we have 7.9 times 10 to the negative 8th and minus 3.6 times 10 to the negative 7th. I want to do this example because we have negative exponents here. So we just need to remember what happens when we move on a number line with negative numbers. So we're going to go to the larger power of 10, which in this case, the larger power of 10 is actually the negative 7, because negative 7 is more than negative 8 on the number line. So I'm going to be moving my power of 10 this way on the number line, and that gives me 10 to the negative 7. So it's one where you might have to just stop and think for a second. And then if I move this way on the number line, I'm going to move that way in my with my decimal. So I have 0.79 times 10 to the negative 7th minus 3.6 times 10 to the negative 7th. I have same powers of 10 now. So I'm going to keep my 10 to the negative 7th. And then I have 0.79 minus 3.6. So if I go plug this into my calculator, I will end up with negative 2.81, and that's times 10 to the negative 7th. So pay attention to what direction you need to move negatives on a number line. And also, it's okay to end up with a negative answer here. So negative 2.81 times 10 to the negative 7 is our final answer. Okay, last but not least, if we look at skill check C, it says light travels at 186,000 miles per second. Sound travels at 0.2 miles per second. So we have 186,000 and 0.2 for light and sound. And it says convert them to scientific notation. So we just need to remember how to convert to scientific notation first of all, just in case. And we've been kind of converting back and forth in scientific notation, but we haven't actually been going straight from a number to scientific notation. So we put our decimal where that's where our decimal is right now, because $186,000 is $186,000, period. Then what we do is we move our decimal down to scientific notation. Remember, we have to have one digit in the ones place, that is either 1, 2, 3, 4, 5, 6, 7, 8, or 9. We're going to go 1, 2, 3, 4, 5. We move 5 spaces. So this is 1.86 times 10 to the 5th power, because we moved to the 5th power, or we moved 5 spaces. With this one, we're going to move our decimal over 1 this direction, which is 2.0 times 10 to the, and we moved to the right, which means we're moving to the left on the number line, which means we're moving to a negative position. So this is negative 1. Then it says, find the ratio of speed to light. Or sorry, speed of light to speed of sound. So we're going speed of light to sound. So our light is 1.86 times 10 to the 5th. And remember, when we're doing a ratio, it has to be in the order given. So we've got the light, then we've got the sound, which is 2.0 times 10 to the negative 1st. And then we can also remember that a ratio is a fraction, or can be written as a fraction or a division problem and calculated. So we're going to actually do the 1.86 times 10 to the 5th over, or divided by, 2.0 times 10 to the negative 1st. And this is kind of a review of what we did yesterday with dividing our powers of 10. So when we're dividing these powers of 10, we divide our numbers, and if you plug 1.86 divided by 2.0 into your calculator, you will end up with 0.93. Double check it. And then, what do we do with our powers of 10? When we're dividing powers of 10, we do the next easiest thing from division, which is subtraction. So we subtract the variables. Or sorry, not the variables, the exponents. So we have 5 minus negative 1 for our exponents here. And 5 minus a negative 1 is the same thing as 5 plus 1, which is 6. So this is 0.93 times 10 to the 6th power. That is our ratio, except that it's not in scientific notation yet. So to change it to scientific notation, we're going to move our decimal 1 place to the right, so we have 9.3, which means we're going to move our number on our number line 1 place to the left, which is times 10 to the 5th. And I know it's the weekend, but I need to make sure you understand what you're doing. So your homework is, it's only 6 problems. You can probably finish most of them before you even leave the classroom. Page 263, 17 through 22. Okay? Pay attention to your powers of 10 to know whether you need to change them or not before you add or subtract. And then we're going to have a quiz on Monday on these last couple sections, but because it's a Monday quiz, you will have open notes. However, open notes means you should take your notes home and familiarize yourself with your notes so that you know where to look for something if you need it. Okay, so homework, 6 problems on adding and subtracting, quiz on Monday, open notes, that's on everything we did this week. I think it's 5.6 through 5.8. And then if you have any questions, please email me, and I will see you on Monday.